Around IT in 256 Seconds by Tomasz Nurkiewicz. Episode 13. Cassandra.
Cassandra is an open-source NoSQL database. It's heavily optimized for writes, but also has intriguing read capabilities. Cassandra has near-linear scalability. In terms of CAP theorem, it favors availability over consistency. Interestingly, despite NoSQL label, Cassandra tables have strict schema. Also, Cassandra query language is similar to SQL. Writing data to Cassandra is very clever. It involves two components, writing record to an append-only commit log on disk and updating mem table. In principle, Cassandra works in memory, storing most recent inserts and updates in mem tables. If the node crashes, data can be retrieved from a commit log. As you already know from the episode about Kafka, append-only files are very cheap. When memory is full, contents of mem table is flushed to disk to so-called SS table. Once written, SS tables are immutable. If you update the same record multiple times, two things can happen. Either you overwrite previous version in mem table, which is cheap, or the previous version was already flushed to SS table, so you now have two copies. Obviously, having one outdated copy of a record is unfortunate. Thus, Cassandra will transparently merge SS tables during compaction. Also, deleting records is quite costly. You can't remove from the immutable SS table. Instead, you create a special tombstone record. In order to understand how reading from Cassandra works, you must be familiar with a few concepts. First of all, data is spread between partitions and partitions are assigned to virtual nodes. The number of virtual nodes, vnodes for short, is fixed and much larger than the number of physical nodes. Cassandra dynamically allocates vnodes to physical nodes. This allows transferring very little data when cluster shrinks or scales out. You have full control over partitioning. Each row has a primary key consisting of a partition key and optional clustering columns. The partition key defines in which partition to look for data. Knowing partition, we quickly find vnode. Knowing vnode, we find physical node. Clustering columns are used for sorting. Despite having tables and columns, Cassandra is actually a sophisticated key-value store. You can only query data by primary key or by the beginning of it. By beginning, I mean partition key or partition key and some clustering columns. This supports fast, sorted range queries. It works because data within SS table is sorted when written down. Querying by other columns is discouraged. Knowing partition is not enough. If given record is available in mem table, it's great. Otherwise, we must find all SS tables that may contain it. Specifically, if the last version is tombstone, it means the record was deleted. Another interesting fact, inserts and updates are almost indistinguishable in Cassandra. Cassandra is implemented in Java. This means it may be occasionally very slow to respond when JVM performs garbage collection. The database tries to work around that by implementing so-called speculative execution. Because data is almost always replicated across multiple nodes, client first asks the closest node. However, if that node does not respond fast enough, it speculates that other node may reply faster. At this moment, we wait for the fastest one. More radical approach was to re-implement Cassandra in a non-managed language like C++. That's how unofficially ScyllaDB was born. Same concepts and API, different technology, and much faster. That's it. Thanks for listening. You can also subscribe to the mailing list, link in the show notes, to get transcripts and more extra materials. Bye!